Hello everyone, in this video we are going to define and implement a neural network for the solving of the XOR problem. So four clusters of data A, B, C and D are defined in a two-dimensional input space in which A and C and B and D clusters represent the XOR classification problem. The task is to define a neural network for solving the XOR problem. The steps we will use in this code is to first of all define the four cluster of input data and then define the output coding for XOR problem. In third step we will prepare the inputs and outputs for the network training, and in fourth step we will simply create and train the network, and in fifth step we will just simply plot the targets and network response to see how good the network learns the data, and in the sixth and in last step we will plot the classification results for the complete input space. So here is the first step. In first step we will define the four clusters of data which are defined here A, B, C and D, and we are taking 100 samples for each class. Now here we are going to plot all these clusters, and then we will label all these four clusters as class A, class B, class C and class A, class B and class C will be also defined as class A, and class D will be defined as class B. Now we will encode the clusters A and C as a one class which will be defined as A, and B and D will be another class which will be defined as B. So A and C has the same value -1 and B and D has the same value 1. Now we will define the inputs, which means that combined all the samples of these four classes, which is P equal to A, B, C and D, and in fourth step we will define the targets. So in next step we will define the targets, and the fourth step is to create and train the neural network. So net equal to feed forward net of 5,3. we have 5 classes, so we will just simply take one more class for assigning them 1 or 0 as a value. So here is the training. Net dot divide by parameter dot train ratio equal to 1, which is training set, and net dot divide parameter dot VAL ratio equal to 0, which is validation set, and net dot divide parameter dot test ratio, which is test set. So we will train as neural network using train command, and now we are going to show the network using the command view of net. So now in fifth step we are going to plot the targets and network response to see how good the network learns the data. Okay, and the last step is to generate a grid or to simply plot the classification results for the complete input space. So I'm going to run the code. So here is our input data, class A, and this is also class C, but we have defined the two classes as one class. So class A, class B and class B. Here is our neural network input, first hidden layer, second hidden layer, which was 5,3, and this is the output layer, and now the output. So here is in this window we will show see the performance of all this neural network, performance, gradients, validation checks, etc. So now this is the simple target response and the network response, which is same. If I zoom it, you can see that both are the same lines. So here is the classification result, where class A and class C was classified as class A, and class B and class D is classified as class B. So here we have the classification results. Thank you.